You're taking a human geography class and you're learning the basics. I know what you're thinking. Geography is where things are, like countries and capitals. Well, yeah, that's part of what geography is. That's not all. Geography is everywhere. It's so much more than just countries and capitals and coloring maps. According to the English Oxford Living Dictionary's website, geography is the study of the physical features on the Earth and its atmosphere, and of human activities as it affects and is affected by these things, including the distribution of populations and resources and political and economic activities. Have you ever heard your teacher describe the spatial perspective with the phrase, where of why? The reason that you hear this phrase so often in a human geography course is because geographers are focused on answering two basic questions when studying the field. Number one, where are people and activities found on Earth? And number two, why are they found there? Hence the where of why. Geographers work tirelessly to discover why and how we use space in the area of the Earth in the ways that we do. And why do our ways of distributing ourselves and our activities differ from place to place across Earth? Geographers rely on tools to help us accomplish the task of answering the questions I just discussed. Probably the most well-known tool in the geographer's arsenal is a map. What then is a map? Well, simply, it's a two-dimensional scale model of the Earth, or a part of the Earth. And notice I said 2D. Isn't the world a sphere, meaning that it's a three-dimensional object? Well, this causes a fundamental problem with maps. Have you ever tried to flatten out an orange peel? If you have, you'll find that it's impossible to do this without screwing up something on the surface of the orange peel. Well, usually if you do it right, it leaves some sort of weird shape that no longer represents a spherical object in any way. The point I'm trying to make is that one does not simply make something flat out of something round. So geographers use projections to show certain parts of the Earth's surface, or to serve some practical purpose. If you Google what is a map projection, you'll get this response. A method for representing part of the surface of the Earth or celestial sphere on a plane surface. Another more simple way of defining projection is the scientific process by which one transfers a location from the Earth's surface, which is curved, to a flat map. There is usually a lot of math involved in this process, but we're going to look at it from a very simple standpoint. There are three main kinds of projections that you're going to see most maps used today. They are cylindrical, conic, and planar. The cylindrical map projection would be like if we wrapped a piece of paper or a piece of notebook paper around a baseball. A conic projection would be like if you made like a cone shape and then stuck it on top of the baseball. And finally, a planar projection would be like what you would get if you would just simply put the paper on top of the baseball and look down straight on it. In each of these projections, however, you should be quick to notice distortion. Distortion is something that is not quite right. It may be a representation of reality, but not quite actual reality. When you add distortion to an electric guitar, for example, it causes the strings to go from that acoustic sound to the hard rock sound that we're all familiar with, like in my intro music, for example. Well, distortion works the same way on a map. To quote atlasandboots.com, the best way to describe how a map projection works is by imagining a piece of paper, the map, being laid over the Earth, or a globe, to obtain latitude and longitude lines from the map. Where the piece of paper touches the globe, there is no distortion on the map. It is an exact reflection of the globe. However, where the paper is not flat, distortion takes place. The further the paper is away from the surface of the globe, the greater the distortions. In other words, a cylindrical projection will make the equatorial regions look the most accurate, a conic projection will make the mid-latitude regions of the northern and southern hemispheres look most accurate, and the planar projection will show you what Antarctica actually looks like. It's not actually just this huge white blob mass at the bottom of the Earth. In the next video, we're going to take a little bit of time to look at specific map projections that you may encounter throughout any geography class, and that you should know for the test. I hope you'll come back for more. Peace out, students.